our part 2 ng ating fluid flow measurements na problem solving. So here we have problem number 6. We have a water having a kinematic. Okay, wait lang. So water having a kinematic viscosity of 1.3 times 10 to the power of -6 flows in a 100 mm diameter pipe at a velocity of 4.5 meter per second. Is the flow laminar or turbulent? Okay, so wait lang. So ang tinatanong dito lang. So tinatanong dito kung yung ating flow ba laminar ba or turbulent. So yung ating determination if the flow is laminar or turbulent, gagamitin natin yung ating Reynolds number. So ang ating formula sa Reynolds number is V or yung ating velocity times diameter and then yung rho ng ating density ng ating liquid times doon sa ating kinematic viscosity. Okay, sandali lang. Ito pala. So since yung ating kinematic, given naman yung ating kinematic viscosity. So okay, yan. So ipang write up natin yung ating data doon sa mga variable natin. So meron tayong velocity na 4.5 meters per second. Diameter na 100 mm. But ang gagamitin natin in terms of meters, so 0.1 meters. So ito. And then yung ating kinematic viscosity na 1.3 times 10 to the power of -6 meter squared per second. So ilagay natin siya sa ating equation. So meron tayong 4.5 meters per second times 0.1 meter. So divide natin sa ating kinematic viscosity na 1.3 times 10 to the power of -6 meters squared per second. So makita ninyo, i-times natin, di ba ito? Ito mga unit ha. So dito sa upper portion ng ating fraction is meters squared per second. So magka-cancel out lang siya, di ba? Dito sa ating value sa baba. Since yung ating Reynolds number is a dimensionless value. So wala siyang unit. Only the number only. So RE natin is equals to anong kanyang value? So we have a Reynolds number na 346,154. Okay. So greater siya doon sa ating parang borderline, parang range na 2,300. So pag lesser than 2,300 laminar. Pero since mas malaki itong value na to, 100,000 good. So this flow is a turbulent 1. Okay, so turbulent flow. Okay, so problem number 7. So problem number 7, oil of specific gravity na 0.8 flows in a 200 mm diameter pipe we will find its critical velocity and we will use yung ating absolute viscosity ito itong term na to. Absolute viscosity na 8.14 times 10 to the power of -2 pascals second. At a critical velocity in pipes, yung ating Reynolds number equals to 2,000. Okay? So yung ating critical velocity is at Reynolds number na 2,000 dito sa ating conditions. So, ang ating Reynolds number here in terms of absolute viscosity is, ang formula is yung ating velocity times diameter times dun sa density ng liquid o ng fluid over our absolute viscosity. So, yung ating velocity is wala. Hindi siya given. So, yun nga ang ating hinahanap. Okay. So, ang ating diameter is 200 mm. So, convert sa meter, meron tayong 0.2 meters diameter. And then, yung ating rho is oil man ito, no? So, 1,000 times 0.8 na specific gravity. Okay? Tapos, ang ating absolute viscosity na 8.14 times 10 to the power of -2 pascals second. Tapos, yung ating critical velocity, RE is 2,000. So, ito yung ating gagamitin na RE. So, input na natin lahat dito na equation or formula. So, meron tayong 2,000 na RE. Reynolds number is equals to yung velocity natin, nga hanapin. That's yung ating diameter na 0.2 times dun sa rho ng density ng fluid. So 1,000 times yung specific gravity na 0.8 over yung ating absolute viscosity na 8.14 times 10 to the power of -2. So, yan na yung ating equation. So, isa lang yung ating unknown variable. So, pwede na siya mahanap. Pwede nang i-input sa calculator, shift solve, yung ating critical velocity value is 1.0175 meters per second. So, ito yung ating answer for the critical velocity. 1.0175 meters per second. So, that's our answer for the problem number 7. So, next, problem number 8. Okay, medyo mahaba ito ha. Ano? Okay lang ito. Next problem yung medyo mahaba. So, for laminar flow conditions, what size of pipe will deliver a 6 liters per second of oil having kinematic viscosity na 6.1 times 10 to the power of -6 meters squared per second. So, since ang ating equation is in terms of kinematic viscosity, so balik tayo dun sa ating problem number 6 na formula for Reynolds number. So, Reynolds number equals to velocity times diameter times kinematic viscosity. Okay? So, iano pa natin to ha? I-expand natin tong formula na to. So, wait lang. May alam mo na. Write up muna natin yung mga given para maintindihan ninyo bakit natin siya i-expand itong formula ng ating Reynolds number. So, yung given natin, meron tayong deliver 6 liters Discharge ito ha, itong 6 liters per second. Okay? Of oil. Tapos kinematic viscosity na 6.1 times 10 to the power of negative 6 meters squared per second. Since naka-ano tayo ha, naka-meters, so yung discharge natin is i-ano pa natin siya, i-convert into meter cube. So i-divide lang natin siya into 1,000. So meron tayong 6.006 meter cube per second na value para sa ating discharge. So ito yung ating mga given. Tapos ito yung ating hinahanap. Okay? Kaya para malaman ba yung ating malaman natin yung ating D or yung size ng ating pipe. So, mag-expand itong ating formula ng ating Reynolds number into yung ating velocity, 'di ba? From discharge siya. Kasi wala man tayong velocity. So, dito natin siya kukunin sa discharge na equation. So, or formula. Area times velocity. So, yung velocity natin is in terms of discharge over area. Okay? Tapos, yung area natin is expand pa ito siya. So, discharge over pi over 4 d squared. Okay? So, i-input natin siya dito. So, magiging discharge over pi over 4 d squared d over kinematic viscosity. Okay? So, ating RE, di ba? For laminar flow conditions, may term dito na binigay, laminar flow conditions. Nagiging floor kasi yung napagka-mention kayo, sorry. So, for laminar flow conditions, yung ating RE is dapat pasok sa 2,000. Di ba? Okay, so 2,000. So, yung ating RE dito is 2,000 is equals to yung discharge natin na 0.006 over pi over 4 d squared d over 6.1 times 10 to the power of negative 6. So, maka-cancel out ito siya. So, ito. Cancel out, diba? So, magiging 2,000 is equals to 0.006 pi over 4 d over 6.1 times 10 to the power of negative 6. So, yung ating D, ito yung ating hinahanap na variable. So, shift solve sa calculator. Yung D natin is 0.626 meters. Or in terms of millimeters, 626 mm. So, ito yung ating diameter ng ating pipe. Okay, so ito yung answer natin for our problem number 8. So next, problem number 9. So yung problem number 9 natin, oil having a gravity, having a specific gravity of 0.869 and dynamic viscosity na 0.0814 Pascal second flows through a cast iron pipe at a velocity of 1 meter per second. The pipe is 50 meters long and 150 millimeter in diameter. So, A, find the head loss due to friction. So, head loss due to friction. Okay? So, dito muna tayo mag-start. So, ang gagamitin natin dito is yung ating RE. Okay? So, kasi ang friction natin, ang formula niya is 64 over RE. So, kukunin muna natin yung ating Reynolds number. So, yung Reynolds number natin is velocity times diameter times density of fluid times dun sa ating dynamic viscosity. Okay? So, ipang-input na natin ano yung mga values na given ha. So, meron tayong velocity na 1 meter per second. Meron tayong diameter ng pipe which is 0.15 kasi 150 mm man. So, in terms of meters, 0.15. Next, yung ating density of fluid. Since this is oil, and then meron siyang specific gravity na 0.869. So, diba yung raw density is 1,000 times dun sa specific gravity na 0.869. And then yung ating dynamic viscosity na 0.0814 Pascal second. So lahat na to, meron na tayong mga data. So ipang-input na natin para makuha natin ang ating Reynolds number. So 1 times 0.15 times 1,000 times the specific gravity of 0.869 over yung ating dynamic viscosity na 0.0814. So ang ating RE, ang kayang value is 1,601. So this flow is a laminar, di ba? Okay. Next, kunin natin yung ating friction. Friction. So, 64 over RE na 1,601. So, meron tayong friction, a value na 0.04. So, kukunin na natin yung ating head loss due to friction. So, ang formula nito is F, yung ating friction, times dun sa length ng ating pipe over the diameter. Times yung ating velocity squared over 2G. Okay. So, meron na tayong mga value, no? May velocity na tayo, may friction na tayo. Yung length natin is 50 meter long. Diameter is 0.15. And then yung G is yung gravitational pull na 9.81. So, input the values yung or mga given data. So, meron tayong 0.04 times 50 over diameter na 0.15 times sa velocity na 1. So, 1 squared over 2 times 9.81. So, with this, ang ating head loss due to friction is 0.68 meters. Okay, so ito ang ating value regarding sa ating head loss. Head loss due to friction. So, that is our answer for our letter A. So, para sa ating letter B, okay, wait lang ha. Erase muna natin. Linisin muna natin ang ating screen. Okay, sandali lang. Okay, malapit na. Okay, letter B. Letter B is, hanapin natin, we will find the shearing stress at the wall of the pipe. Okay. So, ano ang ating shear stress formula? So, ito yung ating representation. Bali. So, ganito. Is equals to unit weight ng ating fluid times dun sa ating head loss times dun sa diameter over 4 times dun sa length. So, lahat na to meron na tayong mga value, di ba? So, i-input lang natin since ito hindi pa natin to siya nakuha. Pero madali lang ito. So, unit weight is in terms of newtons tayo ha. So, 9,810 times dun sa specific gravity, 0.869. Okay. May head loss tayo na compute kanina na 0.68 meters. And then diameter na 0.15. And then length na 50 meters. Okay, so ano na natin, input na natin siya. Input na natin siya dito. So, yung ating shearing stress due to at the wall of the pipe is, meron tayong equation na 9,810 times yung specific gravity ni 0.869 times sa head loss na 0.68 times the diameter na 0.15, then 4/4 times nung sa length na 50 meters. So, ang ating shearing stress is, may value tayo na 4.34 pascals. Okay? Since ang ating ano ko yung mga unit niya ha. So ito Newton per cubic meter. This is meters. This is meters. And this is meter. So mangyayari nito is Newton, matitira niyan is Newton over square root meter square. Square meter, sorry. Newton per square meter or yan yung ating Pascal. Okay? So yung ating shearing stress is 4.34 Pascal. Okay, for the last problem sa ating part 2, number 10. Next is doon na tayo sa ating fluid flow in pipes problem solving. So sa number 10 natin, we will determine the shear stress at the wall of a 300 mm diameter pipe when water flowing causes a head loss of 5 meters in a 90 meter pipe length. B, hanapin natin yung shear velocity. And C, shear stress at 50 mm from the center line of the pipe. So let's proceed sa letter A muna. Okay. So shear stress at the wall. Merong diameter na 0.3 meters. And then merong head loss na 5 meters. And then length na 90 meters. Okay. So yung ating formula for this letter A is the same na sa number 9. Okay, so shear stress, P sub O is equals to unit weight nung ating fluid times sa ating head loss times sa diameter over 4 times length. So, meron na tayong data nito, meron na nito, meron na din ito. So, ano ang ating unit weight ng fluid? So, meron ba tayo? Okay, water lang naman siya. So, ang ating unit weight is, in terms of Newton, 9,810. So, makukuha natin ang ating shear stress at the wall. Input lang natin yung mga data. So, meron tayong 9,810 times sa head loss na 5 meters times sa diameter na 0.3 times over 4 times dun sa length na 90 meters. So, yung shear stress natin sa wall is, may value tayo na 40.90 pascals. So this is our answer para sa ating letter A. Okay, next, letter B. So before that, linisin muna natin ang ating screen. Okay, letter B. Hanapin natin yung kanyang shear velocity. Okay? So yung ating shear velocity, ang formula dyan is V sub S is equals to square root of yung ating shear stress at the wall over the density of ng ating fluid, which is water. Okay, so may value na tayo niyan, di ba? So square root of 40.9 over nung ating density of water is 1,000. So ang ating V sub S, velocity, shear velocity is 0.2 meters per second. So yan ang ating answer sa ating letter B. Okay. So next, proceed na tayo sa ating last question, letter C, which is yung ating shear stress at 50 mm from the center line of the pipe. Okay? So, ang ating formula for this is yung shear stress pa rin is equals to unit weight ng ating fluid times head loss times sa ating, wait lang. Yung ating bagong diameter, which is 50 mm. So, represented natin as X na ha, o small letter D. Okay. Over 2L. Since it is from the center line of the pipe. Okay? Center line of the pipe. So, matunga siya. Kaya naging 2L. Okay? So, meron na tayong mga value niyan, di ba? Input na natin. So, ating shear stress at the wall, at the center line of the pipe is equals to unit weight of fluid, which is 9,810 times ang head loss na na-compute natin, which is, head loss na 5 meters, times sa diameter natin, which is 0.05 over 2 times nung length natin, 90 meters. Oh, mali yung ating representation kanina. So, yung ating pipe, di ba? Center line, gitna. Dito siya. Center of the pipeline, kaya naging 2L. Okay? So, ang value ng ating shear stress from the center line of the pipe is 13.6 pascals. Okay. So, ito na yung answer natin. Ito yung answers natin sa ating problem number 10. Then, sorry, may aking cellphone. So, dito nagtatapos yung ating problem solving sa ating fluid flow measurements. Next video is regarding sa ating fluid flow in pipes. Okay, thank you for listening. See you at the next video.